Queen Mary 2 is a city at sea. She's the largest and most expensive ocean liner ever conceived. Stood on her end, she's taller than the Eiffel Tower, and her engines are large enough to power Reykjavik. She is capable of crossing some of the roughest seas on the planet, while her passengers enjoy unrivaled luxury. She is unique among ships.
It's everything about her. It's her strength, her speed, the majesty of the ship itself.
In an age when ocean liners have almost disappeared, she is a vessel that few believed would ever be built. But to construct this 21st century icon, the engineers must practically reinvent shipbuilding. In 2007, the world's largest ocean liner, the QM2, is at her berth in Southampton, preparing for her weekly transatlantic voyage to New York. She's only at port for 11 hours. All around her is mayhem. At sea, she earns $60,000 an hour, so a quick turnaround is essential. This is a ship that never sleeps.
We arrive around 7 o'clock in the morning, discharge up to 2,700 passengers, embark the same number again, and sail again by 6 o'clock that evening.
As well as loading the passengers and their luggage, the crew must take on huge supplies for the 6-day journey. 4,000 bottles of wine, 2 tons of potatoes, and 26,000 tea bags. So much water is needed, the ship can't carry enough. Instead, the QM2 has her own desalination plant to produce fresh water from the sea, and a wastewater treatment plant to discharge perfectly clean water back out. She must take on 3 million litres of fuel, enough to drive a car to the moon and back 70 times. That's a bill of over $1 million. The Queen Mary 2 sets off on her transatlantic voyage, a 5,000-kilometre journey from Europe to America. This stretch of water once provided a thriving commercial passenger business. Until the 1950s, the only way to travel across the Atlantic was on board an ocean liner. The ship company, Cunard, had a reputation for some of the finest ships. The Lusitania, Queen Elizabeth, Mauretania, and the original Queen Mary ruled the waves. Then, one autumn day in 1958, a fatal blow struck the ocean liner industry, the first commercial transatlantic passenger flight. In a stroke, the journey time was cut from 5 days to 15 hours. 40 years later, and the only ocean liner still doing this crossing was the QE2. Her age was beginning to show, and the once proud Cunard was in deep financial trouble. It looked like the golden age of ocean liners was over forever. No one could see a future for this slow but stately form of travel. No one except one billionaire with a vision. Mickey Arison owns Florida's Miami Heat basketball team. He's also chairman of Carnival Corporation, one of the world's biggest shipping companies.
I saw a television special on what was called the last superliner, QE2, and I remember being very upset by that.
He and his family have a very personal attachment to ocean liners.
I sailed on the Mauretania in 1954 when we immigrated to the United States.
The Mauretania was one of Cunard's classic liners.
I can remember being at the west side of Manhattan and being fascinated by that line of ocean liners that used to dock on the west side of Manhattan.
By the 1990s, the public are spending their time and money in other ways. Ocean liners are a distant memory. But in 1997, Mickey Arison detects a shift in mood.
The movie Titanic had come out, and there was a kind of a nice nostalgic feeling about that movie and about transatlantic crossings. That feeling of nostalgia gave me the sense that if we could bring back that feeling of the great transatlantic voyages of the past, that we would have something special.
And he's prepared to stake his wealth on it. Mickey buys the failing Cunard with the intention of building the greatest ocean liner of them all, the Queen Mary 2. With a price tag of $800 million, the construction of the QM2 could be the biggest risk of Mickey's life. And time is against him. To keep the tradition alive, the QM2 must be ready to take up the baton when the last remaining liner, the QE2, lays it down in 2004. Her sheer scale will present one of the greatest engineering challenges in maritime history. She will be the tallest, broadest, and longest passenger ship on record. Mickey needs a remarkable naval architect to design her. Stephen Payne, senior naval architect, is as passionate about ocean liners as Mickey. When he was 10, Payne's parents took him to visit the newly completed QE2.
As a family, we walked around that great ship for 2 or 3 hours. Really fired my imagination, and I really felt, oh, wouldn't it be great one day to be able to design and build ships such as this?
Payne agrees to take on the QM2, the toughest job of his career. Over a 2-year period, he and his team will have to produce a phenomenal 80,000 design drawings, from the shape of the funnel to the position of the propellers.
I really did sort of eat, sleep, dream, everything Queen Mary 2. It was such a mind-blowing, mind-boggling project to be involved in.
Next, Mickey must find a shipyard with the experience, space, and ambition to build Payne's iconic design.
We didn't have the opportunity to make a lot of mistakes and correct it in the future.
One place stands out, the French Chantier de l'Atlantique, the shipyard of the Atlantic. It has the perfect pedigree, the birthplace of 2 legendary ocean liners, the France and the Normandy, and a crew of 3,000 shipbuilders. Since 1962, they've been making holiday cruise ships. These are more like hotels at sea and not capable of crossing rough oceans at high speed. So they leap at the chance to build a true ocean liner again. They have no time to lose. January 16th, 2002, construction begins with the first of 300,000 pieces of precision-cut steel. 1,500 kilometers of welding and over 10 million rivets will combine to form a ship 3 times the size of the Titanic. The shipyard's chief designer is under pressure.
Delivering the Queen Mary 2 behind schedule would have been a disaster for the shipyard.
Mickey Arison demands that the ship must be completed within 2 years, an incredibly tight deadline. The Chantier team can't afford to relax. Every day the shipyard runs over will cost them $500,000. July 4th, 2002, the first momentous stage in the construction of the Queen Mary 2 is reached. The keel laying.
Current master of
The man who will captain the QM2 presides over the ceremony. After 7 years in charge of the QE2, Warwick's not short on ocean liner experience, and even he is in awe of the megastructure under construction.
I have to say I was totally overwhelmed. I never thought there would be another Atlantic liner, but when I heard that it was going to be a much bigger one, I was in awe of the whole project.
British and French coins are placed inside the keel to give the ship and her passengers luck. The construction team can now join the first steel blocks together. The unmistakable shape of a classic liner begins to reveal itself. Every aspect of this new ship tests the design team. One of the most fundamental challenges is generating enough power. The engines must supply electricity for a community of 4,000 people. This must power the lifts, lighting, air conditioning, water treatment, and everything required for the ultimate in luxury. And that's not all. Huge power is needed to propel the ship across the Atlantic.
On the Queen Mary 2, this is the biggest propulsion system ever to be made.
To reach speeds necessary for the 6-day timetable, keeping the company in business, the ship must produce the energy equivalent to powering 200,000 homes. That's a city the size of Southampton or Reykjavik.
Speed of the ship is absolutely fundamental, and it was of crucial importance to ensure that the ship would be able to arrive and depart on schedule.
Four giant diesel engines are placed deep in the bowels of the ship for stability. Their size means they cannot be fitted into the completed ship. Instead, the ship must be built around them. The pistons are nearly half a metre across and have a capacity 80 times bigger than that of a double-decker bus engine. Each engine boasts 16 of them, and at full throttle pumps out 17 megawatts of electricity. This pushes the propulsion system to 24 knots, as fast as most holiday cruise ships. But unlike cruise ships that are designed for relaxation, the QM2 must be an efficient mode of transport, capable of achieving nearer 30 knots. Payne needs to find a way of generating much more energy. He comes up with an innovative idea. He adds a pair of smaller gas turbines, like those on a Boeing 747, which generate huge power on demand. 50% more than the diesel engines. But there's a knock-on effect.
Gas turbines produce a lot of power for their size, but the biggest problem that they have is that they need an enormous amount of air.
Drawing this air all the way down to the turbines in the engine room through large ducts would take up valuable space. So the designers defy convention and come up with another idea.
Eventually, a very simple and elegant solution was found in that the gas turbines were placed up immediately behind the funnel, where they had full access to the outside air.
The turbines are extremely light, originally designed to fly, so putting them at the top of the ship won't affect stability.
And that's how the problem was solved.
October 2002. With the diesel engines installed, the rest of the ship can now be built around them. With less than 14 months to go before the deadline, the shipyard must work out how they can build a ship twice the size of the QM2's predecessor in half the time. They opt for a technique never used on an ocean liner before. First, they divide the entire ship into 98 blocks. Each block is built separately, with the raw steel being welded into shape in huge workshops. Pre-assembled blocks are then fitted together. One by one, each of these giant sections weighing up to 600 tons is lowered into place. They must be pinpoint accurate. With the sections centimeters away from each other, powerful hydraulic pull jacks hold the blocks in place. The team checks the fit, then welds the section to the growing vessel. It's like putting together a huge 3D jigsaw puzzle. As the puzzle comes together, a critical part of the ship starts to emerge: the hull, which must withstand one of the fiercest forces of nature: the Atlantic Ocean. Rogue waves in the Atlantic have long been a staple of mariners' tales, but cutting-edge science has recently proved they're more than just myth. On the Atlantic Ocean, these waves are a terrifying threat. In 1966, an Italian liner, Michelangelo, is hit by a 21-meter wave on its way to New York. The wave rips open the first-class cabins beneath the bridge and kills 3 people inside. 50 more are injured.
That event really crystallized my thoughts into making this ship as safe and as strong as possible.
Over 50 years, the average North Atlantic wave height has increased by 40%, possibly due to climate change causing more powerful hurricanes. Stephen Payne must create a hull that can withstand an onslaught from the sea. He knows the life of everyone who sails on the Queen Mary 2 depends on his design. He plans 3 groundbreaking elements: an extra thick hull for strength and stability, 50% more than cruise ships. The workers will be trained to weld these steel plates 28 millimeters thick. A radically shaped bow with a protective flare to divert the oncoming waves. And as a last defense, a huge breakwater barrier on the foredeck. Any water that makes it onto the deck will be redirected back into the sea before it tears a hole in the side of the ship.
That really does shout out to the Atlantic, "I'm coming, get out of my way."
Payne's wave-beating design looks impressive on paper and in the shipyard. But the design has to pass crucial tank tests. She must be able to handle the roughest seas without compromising her speed. But this hull shape has never been used before, so no one knows for sure what will happen. Holland has the world's largest seakeeping test basin. It measures nearly 200 meters long by 45 wide and 5 deep, the equivalent of 14 Olympic swimming pools. An 11-meter-long model of the QM2 will test whether the ship can survive the North Atlantic. Guillaume Gaillard is in charge of testing her seafaring ability.
You're making sure that you won't have any bad surprise at the moment the ship is delivered.
Industrial wave machines simulate hurricane conditions.
Stephen Payne really insisted they wanted absolutely to see how the ship would handle the most extreme weather. So of course it's not nice sailing conditions, not pleasant.
The model is then sent into the heart of the storm.
For the vessel, for the Queen Mary 2, this represents waves of about 16-meter significant wave height, which is one of the biggest, most severe sea states you can find in wintertime on the North Atlantic.
The first test begins. Huge waves are deflected to the side of the model's flared bow. The breakwater rapidly disposes of any water that makes it onto the foredeck. Payne's new protective hull appears to work perfectly. But for the next test, the model ship must achieve great speeds. In calm water, it must reach the equivalent of nearly 30 knots. Early results are dire.
First test showed that the shipyard would have very difficult time in actually achieving the contract speed.
The ship must be able to cross the Atlantic in 6 days, or Mickey Arrison's new venture could hit the rocks. Somehow, the QM2 has to go faster. the shipyard must increase the speed of the Queen Mary 2 to fulfill their contract. The pressure is on engineer Henk Valkhoff.
We really had a big problem, and I think people from QNet were expressing their concern also here and say, well, this has to be solved.
The simplest solution would be to increase the power, but the propulsion system is already under construction and cannot be changed.
We gave the shipyard a very, very tight limit on the amount of power they could use to drive the ship for the speed we wanted.
They would have to find another way. Henk Valkhoff turns his attention instead to the bow. As ships move forward, water is forced into a bow wave at the front, which causes resistance.
Here we see a traditional bow. There's a lot of waves and turbulence on front of it, and that's slowing down the speed of such a ship.
Many modern ships, including the QM2, incorporate what's called a bulbous bow to counteract this effect. Water flows up over the bulb. Then, as it comes back down, the two flows of water partially cancel each other out, reducing the bow wave.
When I look at the bulbous bow, like on the Queen Mary 2, you see a significant reduction of drag, improving the speed.
But even with a bulbous bow, the QM2 model is not fast enough. In a bold move, Valkhoff increases the size of the bulbous bow by nearly 2 meters for maximum effect, making it at 12 meters longer than ever before on a passenger ship. The model finally hits its target speed.
We have seen performance improvements up to 15 to 20%. So this ship is so fast, I cannot keep up with it.
The shipyard engineers are back on track, but it's not plain sailing yet. No one will want to pay up to $30,000 per cabin to cross the Atlantic in a ship that makes them feel seasick.
On a cargo vessel, all the cargo is secured. On a passenger ship, we don't tie the passengers down.
Stephen Payne has a better solution. He plans to use well-established technology, but on a large scale. He adds 2 pairs of huge stabilizing fins. Each has a surface area of over 15 square meters. In calm weather, to reduce the drag, the stabilizers are housed inside the ship's hull. In rough weather, they're deployed at the push of a button to counteract the pitch and roll of heavy seas. The 70-ton fins extend in just 30 seconds to a distance of 6 meters beyond the ship's side. Here they will move through the water like the wings of a plane. The new stabilizers cut roll by 90% and make the QM2 twice as stable as her predecessor, the QE2. Stephen Payne now turns his attention to the thorny issue of maneuverability.
Yeah, because there's different standards between passenger and crew. Right?
Commodore Warwick knows that he'll need to control the ship's movements very precisely, especially on the Solent, a stretch of water near Southampton.
Solent is a very tight channel for a ship this size, so it's essential that we get the maneuverability of the ship exactly right to accomplish these turns.
Traditional ocean liners are built with shaft-driven propellers for propulsion and a rudder to steer. Not only does this take up valuable space, it also gives limited maneuverability. Payne has heard about a recent breakthrough in marine propulsion known as pods. These cutting-edge devices are used to power the newest holiday cruise ships. They're so effective, they can turn a ship on a dime. But there's a downside. This high-tech machinery has never been used on a ship of this scale. They would be fitting unproven technology.
We had to be very, very careful to ensure that by putting 4 pods on the ship, we wouldn't run into any significant difficulties.
The designers take the plunge. 4 enormous pods hang under the hull like giant outboard motors. Each of these units weighs as much as a fully loaded Boeing 747. Unlike many cruise ships, which are fitted with just 2, the QM2 will be fitted with an unprecedented 4 pods. And they're the largest ever built. The rear pair will be able to swivel 360 degrees, pushing the boat in any direction, so there's no need for a rudder. At the front of the ship, 3 huge propellers called bow thrusters will be set in the hull behind swivel doors. Together, the pods and thrusters will give the world's biggest liner unequaled maneuverability in tight situations.
We can turn this ship around on a pinhead. It's just incredible.
But when the time comes for the radical propulsion pods to be fitted, trouble hits. Similar pods fitted to 4 other cruise ships fail repeatedly. The thrust generated by the propellers transfers to the ship through metal bearings, which are wearing down under the immense pressure. Unable to leave port, the afflicted holiday ships are confined to dock. Multi-million-dollar cruises are cancelled.
It's a very difficult thing when you've got a ship under construction and suddenly you hear that one of the key components of the ship may potentially be a source of problem.
These technical difficulties delay the pod's delivery. The schedule is thrown into turmoil. Soon the ship should motor out of the construction dock and into a larger dock to begin the fit-out, powered by her new pods. But without a propulsion system, the QM2 is paralyzed. Project completion is planned for just 8 months' time. There is only a narrow monthly window when the lunar tide is high enough to allow the transfer, and the pods will not arrive in time. What should be a glorious moment, the first time the QM2 moves under her own steam, is not going to plan. The appointed day arrives, March 21st, 2003, and the pods are still nowhere to be seen. But the construction team can wait no longer to get her into the new dock. At 4 a.m., under cover of darkness, away from the glare of the world's media, the Queen Mary 2 moves out into the river. But she's being pulled by tugboats. Her lack of pods makes the transfer more dangerous and delays the schedule. The shipyards still don't know when they'll be delivered. Construction workers can finally begin phase 2 of the project, the fitting out of the QM2. This task is enormous. Not only is she the largest ocean liner in the world, but the work must be done in record time. In just 8 months, the plumbers, electricians and engineers must fit 2,500 kilometers of electric cable, 500 kilometers of ducts, mains and pipes, 9,000 loudspeakers and 80,000 lighting points. 3,000 fitters must install 1,300 cabins, a nightclub, ballroom, casino and theatre, the largest library afloat, 5 swimming pools, a basketball court, and to top it all, a full-scale planetarium. There is no room for error. Any delays now will push the shipyard team over the crucial delivery date at a cost of $500,000 a day.
Probably the delivery of the ship.
The biggest threat to the deadline is the crisis-ridden pod propulsion system. Finally, after extensive testing and just 6 months before delivery, the new improved pods arrive.
People were hugely relieved because the faults were mended.
The pods are assembled and fitted to the base of the ship. With her own means of propulsion, the QM2 has turned from a steel shell into a functional ship. With the pods taken care of, the final section of the QM2 must be fitted out. The ship's nerve center, the bridge. The construction crew painstakingly install one of the most advanced maritime control centers in the world. The captain has no wheel to steer the ship. A bank of state-of-the-art touch-sensitive computer screens control every process, from precise adjustments of the rotating propulsion pods to a satellite navigation system that gives the ship's exact location. With the interior fit out nearly complete, the QM2 approaches her final hurdle, the sea trials. Cunard will only pay the full bill if the shipyard can prove that she meets the meticulous standards set out in the contract. During design and construction, the ship's components were tested and shown to work flawlessly. But because of the unique design, no one can be sure how the actual ship will perform on the water.
It's always a nervous time, the first sea trials, because it's an unknown. You just don't know what's going to happen.
The only way to find out is to launch her into the ocean. On September 25th, 2003, there's cause for celebration as the Queen Mary 2 sails out of the dock under her own power for the first time.
The excitement on board the ship and within the town of Saint-Nazaire when this ship moved for the first time under her own power was absolutely unbelievable.
For the next 3 days, 40 separate tests are carried out. She needs to pass them all. Anchors are dropped and retrieved. The ship performs crash turns, and the rescue boats are deployed. Everything is going to plan. To test the ship's maneuverability, the underwater bow thruster doors open and they are turned to full throttle. But something's not right.
One of the bow thruster doors inadvertently closed when the thruster was running and the door was blown off.
The heavy steel door sinks rapidly to the ocean floor, leaving a tear in the ship's hull. It's completely unexpected, only 3 months before the deadline. The Queen Mary 2 limps back to the shipyard. This is a grave wake-up call. The hydrodynamics of the ship will be seriously affected.
With one of the doors missing, it would mean that there'd be a lot of turbulence, which would slow the ship down.
The speed trials are in just 4 weeks, but the suppliers can't make a new bow door in time. The shipyard has no choice but to try to make this precision piece of technology themselves. As the engineers worry about the bow door, the decorators also have a huge task ahead of them. 250,000 meters of flooring and carpet and works of art worth $7 million must fill vast public rooms and endless corridors. The hull needs 200,000 liters of red and black paint, but the QM2 must also be thoroughly green, so the paint used is non-toxic to marine life. With just 3 months until delivery, they can't afford any setbacks. After a month of feverish activity, the decorators are well on course to finish by the delivery date, and the engineers complete the bow door just in time for the speed trials. The QM2 is beginning to look like a magnificent ocean liner as she takes to the sea again. The designers have specified that the ship must be capable of a speed of 29.35 knots to cross the Atlantic on time, an ambitious target for such a large ship. The QM2 is tracked by satellite as she makes runs of 1.6 kilometers, measured precisely. On the final run, the helmsman from the shipyard hands control of the ship to Commodore Warwick. As he takes control of his ship for the first time, he turns the engines to full throttle. The speed hits a peak of over 30 knots. With an average of 29.62 knots, she is faster than specified in the contract. Everyone is delighted.
She'd actually performed far better than we had ever expected.
The ship workers are rewarded for their excellent work when Cunard and the shipyard plan an open day. On the 15th of November 2003, the proud workers show off the ship to their families. Visitors stream on and off the liner to see the luxurious rooms inside. But then disaster strikes. A gangway above the dry dock collapses. 16 people plunge to their deaths on the concrete floor 20 meters below. 30 more are injured.
Tragedy of that event was definitely the low point.
Despite the tragic collapse of the QM2's gangway, the workers are determined to finish construction on time. The crucial final touches must be carefully put in place before she'll be accepted by Cunard. Against all the odds, after a month's hard work, the QM2 is finally ready for delivery, on the very day that had been specified 2 years before. On Boxing Day 2003, the completed Queen Mary 2 leaves Saint-Nazaire and is delivered to Mickey Arison.
It was a euphoric day. I felt that we'd really accomplished something very, very special.
Queen Elizabeth II agrees to name her in a spectacular ceremony.
May God bless her and all who sail in her.
The Queen Mary 2 is born. And there has never been a ship like her. So much about her is on the largest scale.
It's her strength, her speed, the majesty of the ship itself, and people feel that when they're aboard.
She has the biggest ballroom afloat, a theatre, the world's only floating planetarium, and the magnificent Britannia dining room. Mickey Arison and Stephen Payne have achieved their dream of creating an ocean liner for the 21st century.
The ship now exists, and it's proving all those people who said there would never be another transatlantic liner absolutely wrong, because the ship is here and she's doing very well.
The QM2 takes over the historic transatlantic route from the QE2. After 5 days at sea, she is a day away from New York and has entered thick fog. Commodore Warwick is responsible for the lives of nearly 4,000 passengers and crew. He has both trusted traditional methods and cutting-edge technology at his disposal. The QM2 sounds her horn every 2 minutes to warn approaching ships. This horn can be heard over 15 kilometers away and was installed in 1935 on the original Queen Mary, after whom this ship was named. Larger dots on the screen represent objects picked up by radar and could be ships, icebergs, or even whales. One of these dots is moving towards the QM2 on a potential collision course.
We've now identified the ship approaching us. On the radar is indicating that she's traveling at 4.3 knots.
The state-of-the-art computer works out the ship's route and calculates that they will pass too close for comfort. Warwick takes averting action.
We've made a broad alteration of course to starboard so that we'll pass well clear of each other.
The QM2 is safely on track. But down in the galley, staff are preparing for the next challenge, dinner. At one sitting, 1,100 passengers will eat their silver service gourmet meal. Within 30 minutes of these diners finishing, the kitchen and waiting staff must turn it all around and be ready to serve the next 1,100. Early the next morning, they finally arrive at the port of New York. This is one of the most testing parts of the voyage. The Hudson River has strong currents that can make docking incredibly hard. All the ship's innovative design elements must work together under the masterful eye of the captain. The satellite system calculates the QM2's exact position relative to the pier, so that the powerful pods and bow thrusters can maneuver precisely into the narrow strip.
20 metres off, maintaining, thank you.
Starboard pod, down to 4. 3 on each pod. 3 on each pod.
Even a slight breeze could blow the ship against the side of the berth, damaging her and destroying a pier.
When we get off the dock, we then have to take a right-angle turn to go into a fairly narrow slip. So this is quite a critical manoeuvre, and we have to be prepared to use a lot of power on our podded propulsion.
Commodore Warwick guides the vast ship perfectly into the berth.
Stop the azimuth pods. 2 ahead.
Thank you.
Okay, that's it, guys.
Once she's docked in New York, the QM2 has just 10 hours to load up, turn around and be ready to do it all over again.